Okay, so we are given that the cosine of x is equal to negative 1/5. The tangent is positive, and we want to find the value of sine x. So we're going to use a Pythagorean identity. And since the sine squared of the angle plus the cosine squared of the angle is equal to 1, when we substitute in negative 1/5 for cosine, and that gets squared, then we can solve for the sine. So negative 1/5 times negative 1/5 is a positive 1 over 25. And we're going to subtract that to the other side so that we can get the sine squared x by itself. So that's going to be 1 minus 1 over 25. And then we need a common denominator in order to subtract these fractions on this side. So then the sine squared x is equal to 24 over 25. And to get x by itself, to get the sine of x by itself, we're going to square root both sides. And so the sine of x is plus or minus, and then square root of the numerator is square root of 24. Square root of the denominator would be the square root of 25, and then we want to reduce. So 24, let's see, that's 2 times 12, 2 times 6, so we can pull out that pair of 2's to the front. So then sine of x is equal to plus or minus 2 square root of 6 over, and then the square root of 25 is 5. So the last thing we need to decide is whether to keep the positive or the negative for that square root, or 2 square root of 6 over 5. And to do that, we're going to look at our given information again. So we need to know the quadrant where the tangent is positive, but the cosine is negative. And if you remember the acronym we learned earlier in the unit, all students take calculus. A stands for all 6 trig functions positive. S is sine and its reciprocal cosecant are positive in quadrant 2. T is tangent and its reciprocal positive in quadrant 3. And then C is cosine and its reciprocal secant positive in quadrant 4. And we're looking for where tangent is positive but cosine is negative. So that's going to be right here in quadrant 3. And sine is negative in quadrant 3. So that means we're going to keep the negative value here, and that's our answer for the sine of x.